Hi all, welcome to the second session. So this session is about running Terasort on HPCC systems. What we will do in this session is briefly go over Azure AKS consideration, few challenges, and a quick demo of running HPCC Terasort jobs. This is a recorded session, but when it's live, feel free to post your questions in the chat window. Quick intro, my name is Shrikrishna Khose. I'm Cloud Solutions Architect at Microsoft, mainly working on cloud native apps, microservices, and DevOps.
Hi, and I'm Steve Griffith. I'm part of the Microsoft Cloud Native Global Black Belt team. So my role is working with customers, building solutions on Azure, in particular anything around the Kubernetes ecosystem, as well as our kind of modern apps platform, things like Azure Functions and App Service and Azure Container Instance and those capabilities. Prior to being at Microsoft, I worked for Accenture for about 15 years, where I ran IT and IS, and I was the director of cloud engineering, building solutions for the insurance industry for Accenture and Duck Creek.
All right, so most of you must know or must have seen Azure. But to level set, it's a cloud computing platform which offers more than 200 products and capabilities across many classes of services. You see in here, we have edge devices as well now. So we have extended the cloud to edge devices. What that means is if you have code that's running on cloud, you should be able to run the same code seamlessly on the edge devices as well. You see in here that we have dev tools and dev services as well to empower the developers so that they can create more innovative apps with all the infrastructure and PaaS services available here. Azure is truly a global service or platform. We have more than 60 regions across the world with more than 160 data centers. One nice thing about Azure is that all of these regions are linked by one of the largest interconnected network on the planet. So it's truly global, and you can run your apps closer to your users.
So let's talk a little bit about what Azure Kubernetes Service is. If you caught what we shared in the keynote session, we talked a bit about the fact that, as we were working with the HPCC team, we started out establishing some benchmarks, then we did some testing on just Azure VMs. But then the goal was really to run in Kubernetes. For those who aren't familiar, Kubernetes is a container orchestration platform. So container orchestration means you have a container, you want to run it on a big batch of compute, right? So you maybe have 100 VMs, maybe you have 5 VMs, but you want to run these containers on those VMs. Kubernetes provides an orchestration capability on top of that that says, okay, how many copies of the container do you want running at all times? If a container dies, it will fire up a new instance, so on and so forth. So it's managing all of the life cycle of that container and all the components around it. You can go and deploy Kubernetes yourself. You can go build your own Kubernetes capability and install it directly from the upstream project. But when you get that, you are responsible for all of the components in the control plane. So you're responsible for the scheduler and the controllers and all of those pieces. What Azure Kubernetes Service provides is it takes all that control plane responsibility away from the consumer, right? So the user no longer needs to worry about the schedule and all that. It's all managed by Azure. So we provide that as a managed service. And in fact, it's actually at no cost to the user. So the control plane, if you go with the default configuration, is a free service that we manage. And we provide a private tunnel from your VMs, which are part of the cluster, into that control plane so that we can run your workloads. So you move from if you look on the kind of left-hand side there, fully your responsibility Kubernetes cluster top to bottom, to something that is largely managed by Microsoft. So we're providing that capability. You're just deploying an AKS cluster. And what we're doing with the HPCC team is allowing you to we're helping them install the HPC platform directly on top of the AKS service via Helm, which is a standard installation platform for Kubernetes. All
right, so to start with, as you know, that HPCC is super powerful platform actually, and it can do many, many things. But to baseline and benchmark, we have to have some achievable goals actually, right? So first thing is that identify what are your requirements for performance, like CPU-wise, memory, disk, and so on actually, right? So we got the requirements, and then what we did was we start with the basics actually, right? So you start with a VM, like you benchmark a VM, then you go ahead and then benchmark a VM scale set. Then you benchmark a Kubernetes or Azure Kubernetes service, for example, right? And then you think, okay, what are the things that you could change and tweak to run a real world test like Terasort on HPCC, right? Now, this is basic, super basic, high-level architecture of HPCC running on AKS. What you see in here is a HPCC cluster running on AKS with couple node pools actually. One node pool is for HPCC cluster services, and then the other node pools are for Thor workers and Roxy workers actually. And then on the right side, you see that the cluster, HPCC cluster, is connected to the storage, shared storage systems. And then on the left is that it's connected to your data center through Express route.
So as we looked at the Kubernetes considerations, so we look at the things that you can leverage in Kubernetes to help the HPCC platform run optimally. There's a few things that we looked at in particular. The first and foremost, you noticed in the last slide that Krishna showed that there was Thor and Roxy pool separation, right? So the idea that certain application components, certain system components, you may want to isolate to specific hardware, right? That's a very common Kubernetes orchestration feature, right? And Kubernetes handles that through the concept of taints and tolerations. So a taint is where you go and say, these nodes, these individual nodes are only expecting to tolerate pods that have this tag on them, for example, right? So a pod being equivalent to a container, right? So you can say, hey, I'm going to taint these nodes as Thor nodes, and I'm going to taint these nodes as Roxy nodes. And what you have to do is in the pod definition itself, you say, I tolerate these taints. So I am a Thor pod. I tolerate any node that has the Thor taint on it. So by adding those capabilities into the HPCC deployment, we're able to then target specific components of the HPCC platform to different compute nodes. And the reason you would do that is maybe for Thor, for example, you might want to have NVMe storage, right? For high performance local disk for things like spill and so forth. So you want to be able to have that targeted capability. The next part was we want to be able to swap out different storage. Obviously, from our testing perspective, we wanted to see the behavior between, say, Azure NetApp files versus Azure files versus blob storage versus blob storage with the NFS adapter, which we'll talk about a little bit more. So having the pluggable storage capability that Kubernetes provides gave us a lot of flexibility there, that we could very quickly spin up a test and switch between NetApp files or blob storage without any issues. And then finally, there's node configurations. Despite the fact that AKS, Azure Kubernetes Service, is a managed service, you do have the ability to go in through a number of different mechanisms, through direct OS config that we provide through AKS, or through privileged daemon sets in the Kubernetes world, the ability to actually modify configurations. And a good example of that would be the MTU setting, right? So we found that in certain tests, if we increased the MTU window for the network interface card, we could get better overall application behavior, overall better performance. So we were able to tune that directly via node configurations with privileged daemon sets in the cluster. So a number of these things that we can do directly in Kubernetes without having to modify the HPCC platform itself, without needing to modify or do anything special on AKS. And these are some of the things that we worked with the HPCC team to get changes into the deployment charts and so forth that you use to enable those features for customers.
All right, so you saw the Kubernetes considerations. Let's talk about Azure and AKS considerations now. So all the Azure VMs, they have a different underlying hardware, and we have to choose one that's optimized for your workload, right? So some come with local disk, which are super performant like NVMe's, but some come with just SSDs and so on, right? The other thing that you have to think about is the network throughput. So some support accelerated network, some don't, right? So you have to think through that as well and consider that as well when you're deploying your VMs or choosing your VMs for the job. The other thing that you have to choose is, or think about, is choosing a right storage option, right? So Azure provides lots actually, right? We have disk, we have object storage, we have services which provide you distributed file systems and so on. So in here as well, we have to choose right storage for the right purpose, right? Like pick fast NVMe's for local spills actually, right? Or pick something like which is bandwidth optimized for Tor, like storage account, or so pick that for that job actually, right? So all in all, we have to pick or choose the storage for the right purpose. The next is AKS consideration or AKS best practices as well. Like as Stu mentioned in previous slide, you have to separate your workers or node pool or jobs in a way that they fit into or run on right node pool. Actually, some are optimized for, say, if you're running something which GPU optimized, you should use that node pool. Or if you're running something like Tor, right, you should run in a way that the node pool support that bandwidth, right? And then you have to then possibly use ephemeral OS disk as well. They are high performant OS devices or disk as well, right? And then another thing that you have to think through or choose is that auto scaling as well. So if you are running clusters and lots of jobs and all that, you can enable auto clustering or auto scale on the cluster level as well, so that you don't have to like sort of manually increase number of virtual machines to run the job.
Another thing that we didn't spend too much time on here, but something to take away for other people who are looking at this is, there are additional features from a security and networking perspective that you may want to consider when deploying AKS. And if you want to look at the Azure documentation, we have what we refer to as the secure baseline content that will show you the best practices around overall securing of the cluster and so forth. So that's not specific to HPCC, just looking at overall when you run production AKS clusters, there's a lot of documentation from Azure to show the best practices for how to implement that.
All right. So from the storage perspective, these are a couple of the storage services that we tested, right? So some are shared ones, some are locally attached actually, right? And some can be mounted as NFS endpoint, or some needs to locally attach to your or to your virtual machine actually, right? Point is that we have so many options and we had to choose right storage for the right purpose actually. Some are here who has fixed IOPS limits, or some has provision IOPS and so on, right? So point is that when you are running HPCC cluster on AKS, you have to think of storage options that you would require for your job. Now, when we started testing all that, we faced a couple of challenges actually, right? So thinking about soft versus hard limits. All of the Azure services or all the cloud services, no matter what the provider is, there are some hard limits and there are some soft limits, right? Soft limits like bandwidth, for example, it can increase up to certain level actually, right? But say, for example, there is hard limit that you cannot get past actually. So when you're choosing specifically for storage, when you're choosing one, you have to think of soft versus hard limits on that storage service, for example.
And that's something. That's something that is documented from Azure. And if you're working with an Azure team, they can help guide you through that process of the potential for increasing those limits. If that's a soft limit, you can typically reach out through support and get that increased. And generally, those are documented in the Azure limits pages for the given service that you're targeting.
Yeah, and then regarding provision versus fixed IOPS as well, as I mentioned that when you are choosing your storage, you have to think through that one as well. Like for example, provision storage, you can provision for your requirements or for your job, but they tend to be costly also. Versus fixed IOPS, for example, if you choose storage account, it will have its own fixed limit or hard limits on that account actually. So you have to think through that as well. The other thing that we have to think or that we saw as a challenge was spilling anything locally actually, right? So when you run HPCC job, like sort job, if it doesn't fit into memory, it tends to spill on local disk actually. So you have to pick a disk or SKU that is optimized for that job, like L or D series, which has super fast disks as well, right? Now, from the Thor's perspective as well, like Thor, as you know, that it's ATL engine and requires, or it is sort of bandwidth heavy actually, right? So you have to choose a storage account which is, or which can support that actually, or storage service that which it can support actually, right? Running that sort of job actually on Thor. Compare that with Roxy. Roxy is query engine, right? So it needs something which is super fast from iOS perspective, right? So we need something like HPCC to run Roxy queries, for example. HPCC cache is a high compute or high performance storage service on Azure, which supports like millions of IOPS actually, and you can have like thousands of nodes attached or querying or getting or fetching data from that service actually, right? So you have to think through that one as well. HPCC Blob versus Blob Fuse versus Blob NFS, right? Now, you have many options, like if you are using object storage for that matter, right? You have many options to get to that storage account or storage service. One is that on HPCC does have its built-in connector or Blob connector that you can use actually, right? Versus there is something called Blob Fuse as well. So what it does is that it gives you a endpoint or for that matter, it can mount a Blob or Fuse on your virtual machine, but it will still work with the REST APIs on Blob storage side actually. Now the final
I
option,
think in both of
yeah.
those cases, yeah, in both those cases, Blob and the HPCC Blob connector, effectively what's happening is there's a translation between the pod and the storage mounted to the pod and REST API calls back to Azure Blob storage, right? So those are essentially being transformed into REST calls. And then the final option there is the Blob NFS, which allows you to have more of a standard NFS protocol-based mount. So you're not going through kind of this REST translation that you'll encounter. So there are benefits to using NFS directly.
Yeah, and the nice thing about that NFS is that you use still the same storage account or service that you created with just hierarchical namespace, and NFS API is open for that one. The other thing is about network as well. So as I mentioned that each virtual machine SKU would have different underlying hardware and all. You have to choose one that is performant for your job actually, right? So pick something that is performant and support something called accelerated network actually. So with this feature, you can go up to like 25 Gbps on the network or on the NIC actually. And then finally for logging as well, it's very essential for you to log things as and when they happen, as well as when you're running jobs and you need something for debugging or just to look closer, like what's happening, why this job is slow or fast as well, right? So on Azure, we have a couple options as well. Like there is something called Container Insight that's built in, but you can very well run any logging service that you would like, but that's something there already. For the real-time monitoring as well, we do have if you are using a built-in logging service, it does have Prometheus operator. But if you want, you could install a Prometheus on the cluster and check and monitor your cluster at real-time as well. Now let's look at the demo quickly. This is the recorded demo. So what I'll do is I'll try to voice over as this happens. So what we have in here is that we have a AKS running with a couple node pools in there. So for the test, what we did was, I think we scaled up the cluster to 200 nodes. So you see here 200 nodes for Thor pool. And then on the storage side, we have a storage with hierarchical namespace and NFS3 API. That's there. And then let's look at the values file. So in here, we have 400 workers running with each one with 18 GB memory and 2 cores actually. Now let's run the job. So this is where we are submitting the job, and that will be scheduled on the HPCC cluster. In here, let's get all the pods and see what's happening. So you see here, the first one is the compile job or compile pod actually that runs. The next up is Tar Manager. You see here in the bottom, that's the pod that's running, which will sort of like monitor or manage all the workers actually. And then after that happens, you would see all the worker pods spinning up as well, right? So they'll come quickly. Like if it's your first run, it'll take a couple of minutes to get all the images on the virtual machine and all that. But if not, if you have run the jobs already, it'll be super fast. Like for example, in this case, it'll be like maybe 20 or 30 seconds. You'll have all your things running actually. And then finally, let's look at the performance for storage as well. So you see here, like we have almost 18 GB per second ingress in here. So that was prep job that was writing in here. But this is just 18 GB. But if you add more nodes or more worker pods and all that, it'll go up to like 25 GB PS or so as well, right? And in here, we have the results actually. So we did couple runs previously, and this is what we see actually. So for prep, it took almost 50 to 1 minute, 50 seconds to 1 minute, and for a short job, it's close to 3 minutes and 3.5 minutes actually. And this was the Terasort job. All right. And these are the couple resources for you to check out after the talk. So we will be posting all the demos, all the code in this code repository. And there are a couple links for the documentation on each service or for each service as well. And please feel free to reach out to us if you have any questions here or emails. Happy to talk to you actually. And thank you.